Hello, everyone, and welcome to this webinar on logging. So my name is Peter. I'll be running this, and I'm coming from a company called Humio, and we're building a new log management tool, also called Humio, and we want to go over aspects of logging. So first, why this webinar? Well, we built Humio in order to, or Humio is built by a team of people that have experience building and running critical software infrastructure and applications for the last many years. And we basically wanted to build something that really fitted our model of viewing the world from a logging perspective. So in this webinar, we'll go through an overview of some of the experiences we've had building or working with logs in relation to Humio and also on previous experiences, and kind of set the stage for how can you make good use of logging kind of from a high level perspective. I have a background as a backend developer. I've been building software systems for the last 10 years. I've been using log management tools in various ways most of my career, and so this is in a large part how I view the world. Yes. So the agenda here today will be first to kind of define what is observability and also set the context of why we actually do logging. Then give a brief overview of the architecture of a log management system. Then I'll come into how can we actually make the logs we have good. Do a demo showing some aspects of logging and how we in Humio can present logs and use logs for good use. And lastly, I'll come up with a small mixed bag of tips and tricks from my career. So first, observability. When I say observability, I mean it in a rather informal way. So basically how you can observe a running computer system and how it behaves, the status and how it behaves. So why do we actually need our IT systems to be observable? So firstly, if we start from the left, we need to discover problems in our IT infrastructure and our applications. We need to be able to fix problems when they are discovered efficiently. We would like to understand the system. So how does the system actually work together? You can gain a lot of insights by looking at logs and metrics and such from a system. We perhaps want to understand how the user is using the system. That's more like from a business angle, getting valuable information on how software systems are being used. We want to do an audit: who did what, when, perhaps also why. Key importance in many sectors. There's also reporting. So kind of what happened the last month, or get a various form of stats that you can perhaps present to business developers or operations overviews. And lastly, forecasting is also important. So how many users do we have now? How many users do we expect to have in 6 months? So all of these aspects is kind of things you want to know, and having an observable system makes this possible. So how are the general tools that we use to make systems observable? So first, starting from left, we log events. Almost all software systems have some sort of event log, and this is kind of the basic layer of how to get insights into what a system is doing. Also, we calculate metrics inside our systems, like the number of requests per second or the amount of memory use and such. And lastly, there's also a lot of systems that kind of pull status from other systems. So like you ping a server, or you make a HTTP request for a status page. so that you can check if your systems are running. So given the ways where we kind of gather and create information about our running systems, we centralize that data, and then we use it for, in all three things. We use it for monitoring and alerting, so that we can very efficiently discover when there are incidents. We do dashboarding and reporting in order to make it much easier to get a quick insight into how are the systems behaving and has been behaved. And then lastly, we do drill down and ad hoc analysis. This is typically when we have an incident or there is a question that we want to get answered that is not of the standard sets that we have. So a key notion here is that in terms of observability, people are often talking about logs and metrics, and those two things are actually two aspects of a spectrum, at least in my view. So logs are events that are happening in your system, while metrics is aggregates of events, so and not the events themselves. Logs have high dimensionality. That means that you can have a lot of extra fields on a given set of events that you can kind of slice and dice on, while metrics tend to have low dimensionality. Logs tend towards structure, being unstructured, even though we are seeing more structured logging currently, while metrics are inherently structured, mainly consisting of numbers. Logs support drill down and analysis to a very fine-grained detail level. Metrics lean towards dashboarding and alerting and monitoring. Logs will vary in volume, while metrics have a fixed volume rate, and logs tend to be high volume, while metrics tend to be low volume. And when I'm saying logs here, I mostly mean debug logs or application logging. So these are kind of the overall characteristics. It's not black and white, but it kind of sets up the framework for it. So in terms of choosing whether to have logs or have metrics, sometimes I see discussions whether to have one or the other. I would actually, in my experience, I would go for having logs, and I'll stop using logs as soon as that gets too expensive. And the reason for this is that logs have more information. You can get more information out of logs than you can from metrics. As soon as you start to aggregate, you lose information. So it is important to do aggregation, because sometimes you can't log everything. You can't log any event that is happening in your system. So you need metrics. But I would kind of start with logs and then create metrics from that to begin with. So when I talk about logging and log management, what are the overall architecture for a system like this? So the basics is that you have a set of backend systems. Then on each backend system, you install a log agent or a set of log agents that will take the logs found in the backend systems or your applications, ship them to a central log management system where you can do centralized analysis across your whole infrastructure. And Humio, what we have built is the purple part, the central log management system. On top of the log management system, you have a user interface where you can do dashboarding and drill down analysis, and you also typically will have some mechanism of triggering alerting or triggering alerts and sending them to an outside system like PagerDuty or Slack or the way you handle alerts. So the key aspect in log management is actually that you have one location where you can search across everything. So if you didn't have a centralized log management system, you would have to log into every server and do look at the logs there. That becomes really infeasible as soon as you have more than 2 servers. Then that becomes a struggle really fast. So, as I said, Humio, we've built a central log management system. The agents that are on backend systems, we actually didn't build that ourselves. And the reason for that is there is a number of really good log shippers out there, or log agents. I just listed 3 here. There's a family called Beats, of which we have a very good experience. We have good experience with them all, but we in particular like one called FileBeat. There's also a log shipper, general purpose log shipper, that can do both shipping logs, but also do a lot of parsing and structuring of logs. It's called FluentD, and similar to FluentD, there is Logstash. Logstash is perhaps even more powerful than FluentD. So for us specifically, we actually just build on top of a really good set of open source tools. There's also many other ways to ship logs. The traditional way in Unix is to ship syslogs, and there's a number of systems that also does that. I just want to briefly talk a bit about some aspects of log shipping. So there are actually 2 categories of sending logs to a central log management system. One is that your applications log to a file system locally on where they are running, and then you have an agent that listens to changes to that file and ship those to the central location. This is can be a bit cumbersome because you have to install an agent on your backend systems, but it does give you some better delivery guarantees, so that the agent can retry later, because the logs are stored on disk. Also, at least for me in particular, I have experienced that you have a log management system, but all of a sudden your network is down and something is wrong, and you're not sure the log management system have the newest info. Then it is really nice to be able to log into a server and just tail the application logs, because that is kind of the foundation, that works. The other way is that you can configure your log shipping or your log libraries. Often you can ship outputters or appenders to your log libraries that can ship directly to a log management system. This will sometimes, depending on how your infrastructure is built, but I would say this tend to be easier to deploy and get working. But also plugins to log libraries tend to be fire and forget, so you may not be able to retry if you can't deliver the logs. If they do cache them locally in memory, you might be aware that it run out of memory. So when you're doing only using a log library, I would say that it's good to know how that fails. So when it can't deliver logs, how does it behave? Because having a log library that crashes your system because it can't deliver logs is really annoying. You don't want your observability infrastructure being the part that kind of gets you in trouble. Also, I've seen a number of times trying to set up Humio that people would like to get the centralized logging and start drilling into logs, but getting the logs into the centralized system can be a bit tricky from my experience. Setting up FluentD and FileBeat and Logstash and all these tools is some of them have quite rich configuration tools or languages that you have to learn first in order to get a good logging experience. So I would suggest start simple and try to have easy log formats. That will make your whole process much better. Just a very quick notice or note on if you have an orchestration tool as your platform, similar to, like, for example, Kubernetes, where logging is provided by the platform, so that you log to standard out, and then the platform will ship logs to a central location. Here, really try to aim for a setup where, when the application developers add a new service, and they will do that because in a microservices architecture, new services will appear often. try to make that self-servant so that they don't have to touch the infrastructure team or have to reconfigure. For example, if you're using file fluentd to ship from a Kubernetes cluster, it's really advantageous to not having to reconfigure fluentd, because if you do an error, you stop the whole log shipping for the rest of the services, and it's if you can set it up so that it's self-service, that is something you should aim for. So next section, when you have logs, then you want to have good logs. So how do you make logging good? Well, actually, there's a very basic strategy for this, and it sounds obvious, but actually, the only thing you need to remember is that you should read your logs. As soon as you start reading your logs, then it becomes evident how you can improve them and make your logging good. So the part here is in read your logs. That's kind of only 3 words, but in order to do that, you actually have to make it easy to read your logs. So this is something that is possible after you kind of set up your whole log pipeline and start to get access to the logs in a very convenient way. Then, but I would say if you take one thing from this whole webinar, it is that you should read your logs. At least that is my experience. So to get good logging, logs are evolved, and they are evolved in several tempi. So the first step is that every time you do some new development or changing code, you will also be adjusting logs. If you create a new module, you will also add log lines, and in that way you'll change what logging comes out. This is just natural to our development. But there's an equally important role in involving logs. That is, as soon as you have systems running in production and you start reading your logs, it will be clear to you that you can improve this. You will discover that you have way too many error logs, or that you have logs that sounds interesting but don't have enough content in order to be usable. So you'll have a smaller feedback loop where you'll read logs and then you'll improve logs, and you'll actually do deployment. At least in my experience, I've been doing deployments that only improve your logging or observability infrastructure in order to simply get better insights in what is happening. And this is the whole circle about evolving logs is key. Logs, it's kind of, it's a first-class citizen. Or more broadly, making your system observable is something you should have or be very aware of. That includes metrics and stuff. So just the 2 set of slides on how could you actually make your logs better. So one thing you should capture in your logging infrastructure is workflows. So every line of code is part of a workflow. That could be a web request, could be some sort of session, it could be a background job or a batch job, but any line of code is part of a workflow. So capture workflows, because workflows tell a story about what your system is doing. Capture lifecycle events of workflows, so start, stop, crashes. Capture progress. If you have in state machines, that could be if you're implementing like a low-level TCP protocol, it has a certain amount of stages that you can go through. Capture that in your logging. Capture metrics, both in general but also at the log level, so timings, sizes, counts. Kind of get the ability to tell a really good story about the workflows you have in your system. Next to that, you want to increase or extend the context of your logging. So that is another way you want to increase the dimensionality. So add IDs so that you can cross-reference between workflows or across a workflow. Add user information, add source file and line number to your logs. Add caller ID for a session or request or job, add the originating ID, put metadata like host or service or pod or task name. So all sorts of context around your logs. This enables you to drill down along axes that you later will discover were key. It's first, you cannot really know how you need to drill down into your data. So demo time. I'll just briefly go through how we do how logging in Humio looks and go through a set of like small use cases from a user's perspective. So filtering first. Just jump over to Humio. So here I have a Humio running. This is the main UI for running Humio. I'm in a repository called GitHub. I'm under the tab called search. So here I can do searching here. And I have a number of other tabs. And currently I'm just showing the number of events for the last 24 hours. So the data behind this is actually, so GitHub, all the open source repositories on GitHub is freely available. You can get all the events happening on open source projects in GitHub. So opening one of those, just to get a feel of what type of data is this. So these are large JSON data structures. And you can see, for example, this specific event was a push event. So some person pushed to an open source repository. That was called, well, the name is here, EHDL. And there's a number of other fields that you have access to. So in Humio, you have the fields directly usable. So if you have structured data, you have the structure. If you have unstructured data, that is also workable. For example, you could say, is there any other events for that specific repo? Just say plus here, and I'll see that within the last 24 hours, 5 events happened for this repository. So here I'm just saying, doing a filter saying with repo.name is equal, I'm not sure how exactly to pronounce that, but that gives me 5 events from the last 24 hours. So filtering in Humio is actually simple. You can do structured filtering as you saw. You can also do free text search. So given that GitHub is for developers and developers likes to write foo bash, we can search for foo bash. So this is actually a shorthand for saying foo and bar and bash. So give me all the events that contain all those 3 words somewhere. So if I open this here event and just search for foo, I can see that it says foo here, bar, and there's a bash here. So that's why this is a result. Could also write for the string foo bar bash. That means that literal string here, and I will get fewer events, but still events. So here you see that there is a specific string here. So it's easy to kind of drill down into Humio. I will also say figure out which repositories is actually writing foo bar bash. So I can, for example, do a group by repo name, and then what I get here is I get a count of all the events for a specific repository, the count of how many foo bar bash events they have. I can actually sort that as well, and then I get this, get it sorted automatically. And so just another example would be if, for example, I want to find all events that have something to Postgres or something to do with Postgres. Repo.name equals Postgres star. So finding all repositories that start with that those letters. I'm just grouping to get the see how many there are. So there are a number of Postgres open source repositories that are getting events. It could be interesting to see what about MySQL. So I could say or repo name should be equal MySQL start. What do I get then? Then I can see that if I sort by here, there will be a number of MySQL statements as well. One interesting search you can do on this data is to figure out which tools that generate the most traffic on GitHub. So I have a saved query here called DBs. And this will show you for the last 24 hours how many events there are on MySQL and in Postgres. And it seems MySQL has lower traffic, at least for the last 24 hours or 48 hours. What I'm doing here is I'm doing the search from before, then I'm piping that filter out to another filter that is a regular expression, where I'm using a regex capturing group. So I'm extracting a field from the repo name, which is just the first 5 characters, and putting that into an event called cat. I can just find that. So now I have a field called cat containing the first 5 characters. And then I'm doing a time chart on those categories, getting MySQL and Postgres. So this is showing that kind of the search language here is you can do filters and you can pipe filters together and you can pipe it over in an aggregate. So time chart is showing graphing. You can do stuff like you can stack them, or you can do stepwise, and you can tweak the style here if you want. So just to show some other aspects of the query language. So this is more or less the same query, but written in another way. We have a case construct. So here we're doing a query or a search query that says, start with a case. If a repo name is the regular expression, starting with Postgres and then something, and searching case insensitive before we search case sensitive. Then we pipe over and create a new field called cat containing the string Postgres SQL. So we are basically anything that where this is true, we put a category field on it. Or we try to do the same for MySQL or MariaDB, and then we put 3 categories on it. And then we do a time chart on cat. So basically the same search, just I would say a bit better because it's case insensitive searching. Now, the result is still that Postgres seems to have more traffic, but again, it's if we do a group by here, the analysis might not be really a ripple. It could easily be things in the analysis that are wrong here. So this Postgres CF bot that these has something to Postgres, something to do with Postgres, but it might also just happens to be something that starts with Postgres. So it might not be an accurate analysis, but it shows off what we can do. Another aspect in Humio is that any query you can do will run on the tail. So if we just say, let's see the logs for the last 5 minutes, then we get the logs in as they come. You see the list of logs change. We could do, remember the logs have a type. So we could try to do an on-the-fly time chart of the types of logs flowing in, and we can see that push events are clearly the one that has the most events, or that is the event type with the most events. I can just speed this up a bit. So this will just flow in as as data comes, and any query in Humio can run on the tail. And this is actually, well, I'll come back to that. That is something that is a really nice tool when you're deploying, or a nice feature when you're deploying. We also show that we have the types. We could say show that as a bar chart, so we can see the count of events per type over the last 5 minutes live. So this is not sorted. Let's just sort this, so we get the most events to the left. Another aspect with having Humio is we could do a dashboard. So I have some pre-configured dashboards. So basically all these dashboards are running live queries. So they're very lightweight. So you have a number of live queries running. This will just illustrate that having dashboards is something that's easily available. Creating a new dashboard is actually quite easy. If we go back to this one, time chart type, and I say save a dashboard widget in title would be dashboard. Then we can go to the dashboard, and it will be available here. And we can move it around and start organizing it. Similar, we can do alerting in Humio. So we say that if we count the number of events flowing into our repository here in the last 5 minutes, if that is bigger than, say, or smaller than 5,000, then this should trigger an alert. So currently the count was I think it was 6,000. So let's say that the limit is 7,000. So we could say that as an alert. Too few events, and we could send an email to me every hour if this is the case. Now we'll have an alert here that right now it's on, and it will start sending me emails. If I change this to 5,000, for example, then we're not in an alert situation because there's no result, and it will be disabled. So again, we can use the live query aspect of our query language to create alerts as well. And alerts, we can have a bunch of notifiers like there's email as this is set up, there's upstream, PagerDuty, Slack, a general purpose webhook. So this was a very brief view on how we kind of make all the logs available to you as a user, and just drilling down and create dashboards. So to end up this webinar, just a mixed bag of tips and tricks. Log levels. So I tend to be confused about what log levels means, and I feel that I talk to other people that are the same. So I normally only use info, warning, and error. And I tend to start out with things I expect is error, discovering that they happen often, like 20 times a day, finding out that this is actually not an error situation. This is just a normal way our system is behaving, and then demoting logs to info. And some people think that an error log should actually wake people in the night, but I actually would say waking people up would be something you should do based on key metrics, like if there's no users requesting your site, then you should be waking up. If you have something that is not responding at all, you should be waking up. A single error log typically indicates a problem, or might indicate a problem, but oftentimes you'll have a reliable system that will kind of take care of that in an automated way. So I tend to go towards just using info logs, and this is something you shouldn't worry too much about your log levels in my experience. Make something that works for you. The other thing is, should you log to a file or send directly to your log management system from your logging library. So I also mentioned this before. I would rather do log to file because that gives me the ability to see the logs on the server directly and don't lose logs in case of you can't deliver them. Log formats. Well, JSON is very nice because you get structure, but so that is a good way, and we're starting to see a bunch of structured logging frameworks. So that is a good option. If you don't, but the problem with having JSON is that, again, if you're looking at the raw logs, because you, for example, need to log into the server and debug, forced to that, then looking at JSON can be difficult. So I often prefer to do like a standard application log, like the example down here, with a timestamp, and here it has a thread, log level, class name, and then a message, and then a set of key value pairs. So this is kind of a good mix between something that is easy to pass and get structure out of, so the key value pairs will get automatically. At the same time, it's fairly easy to read. That's kind of a tend to be a good mix in my experience. If you can, I would group metrics together with logs because then you can cross-reference. A lot of systems have a metric system and a logging system. So I would opt to kind of, maybe it makes sense to have both because you're also doing alerting in your metric systems, but if you can copy all your metrics into your logging system as well, then you can start correlate your metrics and your logs, giving you broader access to information about your system. Small one here, put a GIS hash and your server or application configuration in a startup log, capturing the Git hash of what version you're running will save you trouble when you deploy something you didn't expect, or you're running something that you didn't expect, or you expected to run a newer version and run the old version. That happens. Also having the configuration in your log is the same. You think you actually made a configuration change, but you didn't. Having the application's own word about how it's configured and which version it has can be a time saver. And last is that follow the tail during deployment. So you deploy a new service, do a tail on all the error logs happening across your whole cluster. Because when you deploy a service in one end of the cluster, it might be that you're triggering errors and crashes in a whole other area of your application or your whole system. And just being able to follow error logs while deploying is at least something I have had really good experience doing, very quickly discovering that something went fishy that you hadn't automated logging on. Of course, you need to have a few error logs to make that possible. So you need probably to do some cleanup first. That was actually that. Thank you very much for listening. And you can try Humio for free. You can download it, and you can also sign up for our cloud service. And questions, you can join our Slack community. We have an open Slack community where you're free to join the discussion. And with that, I think I will end this webinar. Thank you very much.